All right, section P3. Okay, this is all about square roots. We're going to take lots of roots in this section. We're going to work with radical expressions as well, okay? So the principal square root of A is denoted by B equals the square root of A, okay? And that square root is always going to be positive or 0. So for example, the square root of 25 equals 5 because 5 squared equals 25. All right, and the only way that you're going to get a negative answer, specifically for a square root, okay, that's important, is if the negative sign is out front. Okay, so what do I mean by out front? So look at this example here. We have the negative square root of 64, okay? So some students like to say that this that I'm highlighting here is like a house. So 64 is under the house. So the only way that you're going to get a negative answer for a square root is if the negative sign is outside the house, okay? Not inside the house, okay? So then we get -8 in that case. So that's the only way that we're going to have negatives running around, okay? With square roots. All right, here's a list of squares, okay? Just from 1 to 10, I squared each value. We're going to use this list. It's going to be on the next page as well for you to look at. But this is just a list of squares that we're going to use a lot. And you're probably familiar with at least some of them, okay? So there it is at the top right. So if we had examples and we needed to simplify the radical expression, okay? And we had something like the square root of 49. All right, well, we can go over to our list of squares. And we have 7 squared equals 49. So that means that the square root of 49 equals 7. Because 7 squared equals 49. Okay? Now, let's do another example. What if we put a fraction under our radical, okay? So we can say, okay, this is the square root of 1/9. So we can take our radical to the numerator and to the denominator. So we have the square root of 1 over the square root of 9, okay? So we just took the square root to the top and to the bottom, and we know that the square root of 1 is 1 because 1 squared is 1. And we know that the square root of 9 is 3 because 3 squared equals 9. So our answer is 1/3. What about the negative square root of 81? Okay, and if you remember what I said just a second ago about negatives, we are okay here because our negative is outside the house. Okay, it's not inside, it's outside. So that we know we're going to end with a negative number, and the square root of 81 is 9 because, let's go up to our squares. Where is it? There it is. Because 9 squared equals 81. So the square root of 81 is 9, and we're going to leave our negative sign there because it's outside the house. All right. Well, look at this one. The square root of -36. Notice the way that I said these two different examples. Up here, I said the negative square root of 81. And on this one, I said the square root of -36, okay? The problem with this guy is that the negative is inside the house. And that is illegal. We don't like that. That is a no-no, okay? So this gives us an error. If you typed that into your calculator, you would get an error, okay? Actually, it's just technically not real. It's not a real number. It is a complex number, and we will get to all of that soon, okay? But for now, all you need to know is that if you are taking the square root of a negative number and your negative is inside the house, that gives you an error. That gives you something that is not real, okay? So, couple of rules. Here's the first one, and we've been doing this one, right? The square root of a squared equals a. So this means that if we had the square root of 3 squared, so your 3 is acting like your a in our generalized rule here. So we just get 3. Okay, so what that radical sign is doing here is undoing your squared term, okay? If I'm squaring something and then I take I square root it, I'm undoing the fact that I squared it, okay? Kind of like how we talk about division undoes multiplication, or multiplication undoes division, okay? So here's a rule that we're going to use. Let's see, next page. Here's another rule, okay? If A and B represent non-negative real numbers, okay, so that just means that they're positive numbers, then the square root of A times B equals the square root of A times the square root of B. So all this is saying is, hey, if you give me a radical, if you give me a square root or any kind of root, and I'm multiplying two numbers under that square root, then I can break it up into one thing multiplied by the other thing. Okay, that's all. So this rule comes in handy when I give you something like the square root of 12, okay? The square root of 12, there's nothing in our list of squares that helps us out, okay? We don't have anything that is a perfect square, okay? Nothing that when we take the square root of it, it's going to give us a whole number, all right? But we do have factors of 12, right? So we think, okay, what are the factors of 12 that are going to help us out? Okay, so we have 4 and 3. Okay, another two factors of 12 are 6 and 2. But also 6 and 2 are not perfect squares. Okay, there's nothing that we can't take the square root of 6 either to get a whole number. It doesn't work. So we're still kind of left in the dark there. But we can take the square root of 4 and get a whole number, okay? So because of our rule up here, we have two things multiplied together under our radical. So that means that we can split it up. And we can say that we have the square root of 4 times the square root of 3, okay? What is the square root of 4? Go back, look at your square, your list of squares that we had. It's 2, right? So this is no longer the square root of 4 because we can simplify the square root of 4 as 2 on the square root of 3. Okay, that's how we say that, 2 on the square root of 3. You can also say 2 times the square root of 3. So if I say either one, I am referring to the same thing. Okay, so we said, nope, we know what this is. That is 2. Okay. square root of 45. Again, it's not going to take you very long to realize that we don't have any perfect squares going on here. We can't just take the square root of this and it be a whole number. So we need to think of the factors of 45 that are going to help us out, okay? Well, 9 and 5. 9 times 5. We're going to apply our rule once again. Whoops. Apply our rule. We're just going to break it up. And we know that the square root of 9 is 3, because 3 squared equals 9. So we have 3 on the square root of 9, because we said, hey, we know what this is. And we get 3. $75, the square root of 75. Once again, not going to take you very long at all to say, hey, this is not going to give me a whole number. I can't take the square root of this and get something that helps me out. So I need to think of the factors of 75 that are going to be helpful to me. Okay, so you're looking for numbers like 4, 9, 16, 25, 36. All of those are going to help you out. All right, so you have 75. Okay, well, that's 25 times 3. And you said, okay, Miss Kelly, that's great that you figured that out, but how am I supposed to figure that out? Well, just go down your list of squares and say, well, 4 can't go into 25, and 9 can't, and 16 can't. And then you get to 25 and you say, oh, 25 times 3 is 75. So that's what I need to split my radical, my number into, okay? So just go down that list, all right? So now you say, all right, apply your rule. So you get the square root of 25 times the square root of 3, and that gives you 5 on the square root of 3. Okay, and you said, hey, I know what this is, that's 5. Okay. So these 3 examples, I ran into an issue and said, okay, these are not anything that's going to be helpful. Like, I can't just do this in one step. I have to break these up. I have to use my rule that says if I'm multiplying 2 numbers together under a radical, I can split them up and take the square root that way, okay? Here's another rule. And we have already used this rule actually in a previous example. Here's a rule. It says if A and B are represent positive real numbers, then the square root of A over B equals the square root of A divided by the square root of B. Okay, so all that's saying again is that I can split it up. I can do it by pieces if you want to think of it like that, okay? So earlier we had the square root of 1/9, and we got the square root of 1 over the square root of 9. Okay, and that simplified to 1/3. Now, let's look at some maybe more complicated examples, all right? So we have the square root of 98x to the 11th all over 2x cubed. And all of that is under a radical. Okay, so your first step, let's deal with your fraction, okay? So we have 98 divided by 2. Well, you have a calculator, and you're just going to divide like you normally do. Nothing changes there. So you get 49. 98 divided by 2 is 49. Now you need to deal with your x's. And if you recall, if you are dividing like exponents, meaning you have an x and you have an x, so I have an x here and an x here, I'm dividing these two exponents. So I subtract my exponents, okay? So I'm saying x to the 11th over x to the third. So I'm saying 11 minus 3. So I get x to the 8th. All right, do you guys see that I just dealt solely with my fraction? I didn't deal with my square root at all. At all. And we can make a note what we did with our exponents. We were dividing our exponents. So we subtract. Okay, so we said 11 minus 3, and we got 8 right there. All right, but we didn't touch our square root, okay? Now let's deal with it. Let me zoom out a little bit. So from here to here is where we will deal with our radical. All right, so we are taking the square root, right? And we normally don't write a 2 right here, but it's going to help us keep us straight, all right? Because there's an understood 2 right there. We're taking the square root. That is the principal square root, okay? So let's write a 2 right there. So we are going to take the square root of 49. All right, well, that's just like the very first example that we worked. That's just a normal square root of a number. So we get 7 because 7 squared is 49. Now we have this exponent, this variable raised to this exponent, and we need to get that out from under the house, okay? Here it is under your radical, and we need to get it out of the house. So what you're going to do when your exponents are under the house and you need to get them out of the house, you are going to divide your exponent by whatever root you are taking. Okay, so I'm taking the square root here. So I'm going to say 8 divided by 2. Well, that's 4, right? So x to the 4th is what I would get. All right, so this is actually your answer right here. 7x to the 4th. And we can make a little note about what we did with our exponents here. So I'll circle them in the color and then write them in the color. Let's see. I can write right here. Okay. So we said 8 divided 2. We said, I'll just write it in words, that we divide exponent by the root. Okay, so we say, all right, so we have 8 divided by 2 gives us 4. Okay. Let's do another one. The square root of 75 x to the 10th over 3x to the 4th. Okay. Once again, we are going to start with our fraction from here to here. Don't even worry about the fact that you are taking a square root. Not yet. We're not worried about that. So now we're going to put back our square root because we're not dealing with it yet. Deal with your whole numbers first, your coefficients. Okay, those are these guys, your coefficients. And you have 75 divided by 3. That gives you 25. And then remember what we do to exponents whenever we divide, we subtract our exponents. So we are saying x to the 10th, x to the 4th. So we say 10 minus 4, that gives us 6, okay? So we dealt with our fraction, we didn't touch our root. Now let's deal with our radical. All right. So once again, we're taking the square root. So deal with your whole number first. You have the square root of 25. Well, that's going to give you 5 because 5 squared equals 25. All right. Then you have to deal with your variable raised to an exponent. Okay. And remember what we did last time. You divide. So you say, okay, here's my exponent. Here's what my root is. I'm going to say 6 divided by 2. That gives me 3. All right, and I'll write, oops. 6 divided by 3 gave me 2. And I'll draw lines. And I'm sorry, I wrote that wrong. 6 divided by 2 gave me 3, my bad. There we go. And so your answer is 5x cubed, okay? So all I did was I gave you 2 rules. I gave you one for multiplication, one for division, all right?